Hi class. Today I'm going to be going over the topics that we've covered so far this unit on functions. So as you go through, I'm going to go mention every lesson, do a brief overview of like what you learned in that lesson, and then at the end of each one, you're going to respond, how confident you are in on this topic for the test. So please be honest. Don't just say, yes, I 100% am confident, or, just say I don't know anything for anything. Be honest, because if more people are really struggling with one specific topic, then I'm going to go over that in the review lesson. So, please make sure you identify. Don't just say I'm not confident for anything, because then I won't know what really to go over and won't be able to spend as much time on it. Okay. And of course, anything that you want to email me about, I'm happy to answer in greater depth. Okay, so the first lesson started off at, I think it was lesson 6. Yeah. And you can always go back into Google Classroom and see the lesson itself, see the video, and rewatch it in case that is another way you can study for this test. So that's features of graphs. Okay, so there's a few terms that you need to understand from this lesson. And most of these are review. The horizontal intercept, which we also know as the x-intercept. But you should be able to identify both, right? The x-axis is that horizontal line. And then, of course, if we have the horizontal intercept, vertical intercept, also known as the y-intercept. And that's that vertical axis, the y-axis. That's why it's called a vertical intercept. You should know what a max is. All right, where or when is y the greatest? So when we're talking about the max, this is the y-coordinate, the highest y-coordinate. Where or when it occurs is also referring to the x-coordinate, because usually, or very often, x is time. So you might say, after how many minutes was the rocket at its max? So the x would be what time that maximum occurred, and the y would be the height itself. Okay. The min follows the same idea, usually talking about a y-coordinate, and then we're talking about where or when is y the least. All right, and the where or when again is talking about an x-coordinate. All right, so if we look at a graph and we have a maximum value here, we're going to have 2 points, an x and a y. The y would usually be the height, or whatever value, the highest cost maybe. And x would be, about when it occurs, since x-axis is usually time. All right, so that's all lesson 6. You should really know from lesson 6. Lesson 7. Using graphs to find average rate of change. And again, this is another topic that is sort of review from earlier in the year, although we are using it in ways that maybe we didn't use it before. So when we talk about average rate of change, we're talking about our change in y, or change in x, rise over run, aka slope. The reason I don't really like to use the word slope is because slope really talks about a linear graph. But we don't need to have a linear graph to find average rate of change. I could have some polynomial function like this that's curved. All I need is to find 2 points, right, the x and y coordinates for them, and then I'm going to find that the slope really that's connecting those 2 points. If I were to draw a straight line, what would that average be? So let's call this point x1, y1. And then this one we'll call x2, comma y2, because I don't know exactly what those points are. It could be any point. Right, the way we calculate this rise over run, I like to stack them. I like to write x1, comma y1, x2, comma y2. Right, then we find what's going to take me from this x to that x, from this y to that y. You might have also seen it written as change in y is equal to y2 minus y1, right? The difference, the change in those two. Change in x, we could see x2 minus x1. If you're going to use this method, I really have not used it, but I've seen many of you use it on tests and exams. It's very important that you keep the second coordinate first and then the first coordinate after that. I guess you could technically also do y1 minus y2, x1 minus x2, but this is normally how it's written. And very important that the graph does not need to be linear. All right, let's say this graph talks about how much money you've saved in a year. All right, so let's say you start saving money and then you spend a little bit, so your savings goes down. Then you spend a little bit more. You can still ask someone, on average, how much money did you save, let's say between February and September? And you might find that, oh, on average, I saved about $2 a day or something like that, right, depending on the problem and the numbers involved. Okay, so that one can be kind of tough and hard to think about, but really it's just taking the two x and y coordinates and finding that change in y over change in x. Okay, that's all that lesson 7 really talked about. Lesson 8. All right, interpreting and creating graphs. We probably will not have anything about creating graphs on this test since I just want to do it all in Schoology. I just didn't get such great results with the people taking pictures and sending it in, and I get how that's not easy for everyone to do, so I'm going to try and stay away from that, especially people who don't have printers. Okay, so for this one, what does the rate of change mean in the problem? So for this, you have to interpret what your x and y values are. Right? Am I talking about miles per hour? Am I talking about, like in this problem, my example, money saved per day, the cost of a ticket per adult? Could be anything. It depends on what the x and y are labeled in the problem. So you're going to have to be able to interpret that. What do the features of the graph mean? Right? Am I talking about the y-intercept? We also know that the y-intercept can be the starting point or initial value. The x-intercept, sometimes we talk about the x-intercept being, if we have a parabola, when is it going to hit the ground? That could be the meaning of the x-intercept. So you have to be able to sort of read a graph and explain it in words. So that's the last thing. What story does the graph tell? Okay. All right, so that's 6, 7, and 8. All right, lesson 9. Was all about comparing graphs. So I think the example they used in the do now was like talking about like the population of Cleveland versus Philadelphia. Obviously, that's not going to be the example on the test, but if you want to look back at the lesson, I think that's the one they used. So if we're comparing these two cities, if we're looking at a graph, I think the graph looks something like this, where they had like a dashed line and then like a solid line. Can you look at two graphs and answer questions like which population was greater? What does it mean when the two graphs intersect? What year was Philadelphia less than Cleveland's population? All right, so you have to also, be able to read those questions in words, but then also know what it means in function notation. So what does, let's say if Cleveland is C of X and Philadelphia is P of X, I could use any letter I want there. What does it mean when I say P of X is equal to C of X? All right, what does it mean when I say P of X is greater than C of X? Or C of X is greater than P of X, all right? So you have to be able to interpret it not only with words, but if they're written in function notation as well. All right, lesson 10. Domain and range. I think actually this was 10 and 11 were domain and range. Okay. What does each word mean? All right, when we talk about domain, talk about our x values, talk about range, talking about y values. It was a little bit concerning on some of the ed puzzles. A lot of people put down one number for domain and range. That is very rarely the case that a domain is one number. It's usually a large span of numbers from a starting point. Right? We always have a starting point and ending point. All right, unless it's infinity, then it never really ends, or we can't reach that point. So you have to know what those words mean. You should never be giving one number value if I'm asking you for domain and range. What are reasonable domains and ranges based on a situation? Right. If I'm talking about human beings, I don't want to talk about negative numbers because human beings are always positive. Also, if I'm talking about number of children, I don't want to be talking about decimals or fractions because you can't have half of a person. Those are only going to be whole numbers. So when am I going to use integers? It's positive and negative whole numbers. When am I going to use rational numbers? All right, those are decimals, fractions. And then whole numbers would just be the positive numbers starting at 0. Okay, so that you have to use a little bit of common sense there. All right, next, you have to be able to look at a graph and determine the domain and range. So if I'm looking at a graph, let's say, draw a quick sketch. I see looks something like this, right? Let's say I've got like an open dot here at 8. I need to be able to write it in interval notation. This should be pretty easy to do on a computer because all you need are the parentheses. I know for my domain, my lowest value is 0. Let's say I've got a filled in circle there. So I'm going to include 0. And I'm going all the way up to 8. And I'm not going to include 8, so I'm going to put a soft bracket. If I want to talk about my range, I can see we're starting at 0, going up to 5. Also know how to do that with inequalities. So if I'm talking about my domain, I know that I can equal 0, but I'm going to be above it. So 0 is less than or equal to x, or x is greater than or equal to 0, and it's just going to be less than 8. For my range, similar idea. So you need to be able to write it like that. I don't know if you can write this symbol in Schoology. I know you can just copy and paste it from Google. If that's the case, you might want to write 0 is less than or equal to x, and x is less than 8. So be able to write that in words as well. Let's say that our y-axis was number of people. I know this really wouldn't be a graph for that. You also should know how to use set notation, right? If I'm talking about number of people, my lowest value is 0, go all the way to 5. I'm going to want to be able to write my range as all the numbers in the set. Right? Those are all the possible numbers I could have for my range. I won't get into the super complex ones. Those you can deal with in Algebra 2. Okay, great. So that domain and range is not easy. That's probably one of the ones I'm imagining people are going to want to spend some time going over. Okay. All right, last few lessons. Lesson 12. And actually, I mean, we did several lessons on this. So there's more than just lesson 12. There was a lot of Edpuzzles on this, talking about piecewise functions. So because it's on Schoology, I'm not going to have you graph anything, but you will be able to look at graphs and interpret things. First off, you should be able to identify a piecewise function. From a situation. Think about that not minimum wage, the overtime problem. Right, once you hit 40 hours, then the function changes. You get paid time and a half. So you have to be able to read a situation and know, is this piecewise and where is that cutoff point? How does the function change? Why? When is it changing? You should be able to determine if it's a function at all. And this really could belong in any of the other lessons, but I'll put it here, right, using the vertical line test. I saw many of you did a good job identifying that in one of the Edpuzzles. You should be able to determine the domain. For each part of the function, or each piece of the function. Right, I might give you something like this, a graph, where let's say you've got a quadratic, and then you've got a flat line, and then you've got a line like that. It's going to be 3 parts, right? So let's say the first one is like x squared plus 4, y equals 8, and then this is like something like 3x plus 2, right? What's going to be the domain for each part of that? You should be able to do that, right? This looks like it's stopping right here. Locate those stopping points, and then say x is less than -2. X is between -2 and +2. x is greater than -2 for each of these three parts. So that's not so easy either. So that's going to make sure you did all those Edpuzzles I put up on piecewise functions. Okay, this one we spend a lot of time on in the Edpuzzles. Determine outputs given inputs. What does that mean? If I tell you, what is f of 8 equal to? Well, I'm not going to plug 8 into this first function, right? That's all the way over here on the left. If I want to go when x equals 8, that's going to be this last function down here. So I would do 3 times 8 plus 2. Definitely going to have a problem like that. All right, so that's pretty much it for piecewise. Lesson 14 and 15 I'm going to kind of group together because they're both special types of functions. So we've got absolute value and root functions. So you should be able to, for absolute value functions, identify the vertex. They're very similar to parabolas. We talked about it. We have an absolute value function. That value h comma k is sort of that vertex of the graph. Root functions, we got f of x is equal to the square root of x. All right, if whatever's inside this radical, right, must be greater than or equal to 0. You can't have a negative number inside that radical, right? Because what does a radical mean? Well, a radical is asking what number do I multiply by itself to get the number inside here. If I've got radical -2, there's no number I can multiply by itself to equal that negative, because a negative, well, if I'm doing a negative times a negative, that's going to equal a positive. If I do a positive times a positive, that's also going to equal a positive. There's no combination of the same number that could possibly give me a negative number there. So be able to identify these functions and evaluate them. If I say, what's, f of 4, you should be able to tell me what the square root of 4 is. That's equal to 2. Remember, this is a principal root. Meaning it must be positive. We did some problems earlier in the year where we did like f of x, or I'm sorry, not f of x, where we did x squared equals 4. When I bring the radical into it, right, it wasn't there to begin with, I brought it in. Now we can get plus or minus 2. When it's already there, when you see the radical already written out, it's only talking about the positive roots. All right, when we talk about absolute value, we're really talking about distance from 0. All right, so 4 and -4 are both 4 away from 0, so those two values are equal. Simply put, negatives and positives are always going to be the same. All right, so that's all the topics for the test. Hopefully this made you feel prepared, or at least help you identify what you want to go over. And then tomorrow we can go over some problems to make sure we're all ready for it. All right, have a great day.